Hello guys, welcome back to my channel. It's on African motifs. In this platform, we shall be focusing on the question paper, which was written November 2009. That is for paper 1. So as we can see here, the instruction, make sure that you read your instructions, everything. So especially on the omission of essential working, which will result in loss of marks, then the decimal answers which are not exact should be given correct 3 significant figures unless stated otherwise. Actually that is the major part that we need. So we shall quickly rush through these questions that we are given. And also take note, you are not allowed to be having calculators, neither mathematical tables, no slide rules, no calculators may be used in this paper. So the first part we are given, find the value of 7/8 minus 5/6, giving your answer as a common fraction in its lowest terms. So here we are just applying the normal or the basic way of subtracting fractions. So I'm just going to have my fraction here. That is 7/8 minus 5/6. So as we know that we are supposed to find the LCM of these denominators, which is 8 and 6. That is LCM of 8 and 6, that can be 24. All right, so you can actually use 24 here. So we are going to divide 24 by 8 here, or you could have maybe used another, but that 24 is the easiest one. Okay, anyways, we'll see. So 24 divided by 8 here is going to be 3 times, which is times 7. So it's going to be 3, whatever that you get, you multiply to 7 minus 24 divided by 6, which is 4, whatever that you get, you multiply to 5. So it's 3 times 7, which is 21. So this one is going to be 21 minus 4 times 5, which is 20, everything over 24. So you can subtract 21 minus 20, that is 1 over 24. All right, so that's it for the first part. The item 2, now we are given 0,0404 divided by 0,8. Give your answer as a decimal. Take note, we are already told your answer should be a decimal. So the best way that you can divide is this way. We are dividing by 0,8. So you have to make sure that the denominator here is a whole number. So we just have to multiply by 10 because we've got 1 decimal place. So multiply by 10 over 10. That will give us something like, just move 1 comma to the right, which is going to be 0,04 over 8. So that means 8 into 0 here, that's a 0, comma. 8 into 0 here, that's 0. 8 into 4, that is a 0 again. Then we put a 0 and 4 here, that's 8 into 40, which is going to be 5. So it's going to be 0,05. Okay, the B part, we are now given to express 0,085 as a percentage. So whenever given as a percentage, simply multiply by 100%. Whether it's a decimal, it's a common fraction, just multiply by 100%. So you're simply moving 2 commas to the right. So it's going to be 8,5 since we are now at this point. So it's going to be 8,5%. So that's how you simply work out the percentages. If you're given a fraction or it's a decimal fraction, whatever fraction that you'll be having. All right, state the number of significant figures in the number that you're given. How many significant figures do we have? So we're talking about whole numbers, which is 1, 2. This one cannot be counted because it's not between whole numbers. So here we've got 2 significant figures. The question is for you to state how many significant figures do we have? Okay, so there are 2 significant figures. We only take 0 if it is between all numbers. Maybe if it was 3, 0, 2 like this, it was going to be 1, 2, 3. But this one is not between all numbers, so we just have 2SF. Okay. Anyways, on the B part, we're given a rectangle measures x by 2 and 2x minus 1. Given that x is equal to 3, correct to the nearest whole number. So which means this x that we are being told, it's an approximation which was made. So the question is to find the minimum possible area. So we have got the 2 sides that we are given. The other one is x plus 2, and the other one is 2x minus 1 of a rectangle. So we are supposed to be working with the x because it's the one that was being corrected to the nearest whole number. So what we need is here from this x, which is equal to 3. What is the minimum value that we have from these 3? So remember, I told you guys the minimum value has to be taken as 0,5 from these 3. So it's 3 minus 0,5, which will be at 2,5. That's our minimum value. If it was maximum value, then it was going to be 3,4. If we are talking about maximum, it was going to remain as 3,4. Okay, like that. So I think that's it. It was going to be 3,4. So that is your x here. So in this case, we are working with the x, which gives us the minimum, like the minimum value, which is 2,5. If you round off 2,5, it gives us 3. So that is the minimum value that you can work with. So your x would be 2,5. So if this x is 2,5, the question is now find the possible, the minimum possible area now. So that means when x is 2,5, you're going to add here in place of x is 2,5. So it's 2,5 plus 2, which is going to be 4,5. We do the same here. So it's 2x, which is 2 times 2,5 minus 1. 2 times 2,5, that is 5 minus 1, which is 4. So this one is going to be 4. So now we've got 4,5, here we've got 4. The question is to find the area, and we know that area is equivalent to length times width. So it's going to be the length of 4,5 times the width of 4. That is that will be the minimum possible. So you can multiply 5 and 4 here, that is 20. Got 2 here, 4 by 4, which is 16, plus 2, which is 18. How many decimal places? 1. So it's going to be 18 square centimeters. So this is going to be the area, which is the minimum possible area in this case. So whenever you're told about maximum or minimum possible values, that's an approximation that you're doing. It's just an approximation. Okay, the third question. Factorize completely. So guys, this one, the coefficient of x squared is 1. So it's just direct. You just need 2 brackets that you're going to have here, with x and x. So focusing with 27, what are the factors of plus 27? But these factors, if you add them, they must give us negative 12. So we've got negative 9 and negative 3. So these are the factors, negative 9, negative 3. So we're done on this one. All right, here we just have to group into 2. So here we've got x, which is common. So you can factor out x, you are left with cx divided by x, that's c minus d. What about on these two? So that it can be common, you have to factor out minus 4y here. So it's going to be minus 4y, so that it becomes, c becomes a positive. You factor out minus 4y, this c is going to be a positive. Minus, plus and minus is going to be a minus. 4 and y, are going to remain with d. So as you can see, the 2 brackets are the same. Therefore, you're going to factor out one of the brackets, c minus d. Then here we are left with x minus 4y, like that. All right, so that's what you're going to have at the end. That's it to number 3. Number 4, we are given a, b, c, d, e, f is a regular. So polygon, that's a regular polygon, a, b. And CD, they're being produced to meet at X, which means we're talking about the exterior angles here. Okay, anyways, this is a regular polygon with our main sides. We've got 1, 2, 3, 4, 5, 6. So which means we are talking about a regular hexagon, which has got 6 sides. So the question is to find or to calculate XBC, that is X B to C, this angle at B. So what does this angle represent? It's an exterior angle of this polygon. So we all know that exterior angles, they all add up to 360 degrees. And we're talking about a regular polygon with all exterior angles equal. This one is equal, this one is also equal. So you just divide by 6. So that would be 6 into 36, that's 60 degrees. All right, so this angle is going to be 60 degrees. Also, this one is also 60 because these two are the same. These exterior angles are the same. All right, so that's it. What about BXC? We've got BX to C. This one there now. So this one we got 60 degrees. Now we want to calculate from B to X to C, which is this one. So we said this is 60, so you can take advantage. Angles near triangle, they add up to 180 degrees. So it's going to be 180 minus 60 plus 60. That is 120 degrees here. So 180 minus 120, which is 60 degrees. So this angle is also 60 degrees. All right, at the last part, give the special name of triangle BXC. BXC, this triangle, it is 60, 66. All the angles are equal. So that means this is an equilateral. That's an equilateral triangle, this one, because all the angles are equal. Or if that means all the sides are also equal. That is the idea of the question. All right, number 5, simplify, just back to laws of exponents. Each and everything you have to raise to the power of 3 here. So it's 2 to the power of 3, x to the power of 3 again. So 2 to the power of 3, x to the power of 3, which is 2 to the power of 3. That is 2 has to multiply itself to 8 3 times. That's 8 x to the power of 3. Just like that, guys. You can see it's 1 mark there. Okay. The p part, which law or concept are you using? Exponent versus exponent. So these exponents can multiply. So this is 8 to the exponent of minus 2 over 3 to the exponent of 1 over 2. So exponent and exponent multiplies each other. So it's going to be minus 2 over 3 times 1 over 2. So this can cancel, which is going to give us minus 1 over 2. So that follows that this is going to be 8 to the exponent of minus 1 over 3. So 2 and 2 cancel, so it's minus 1 over 3. How do we remove the negative from our laws of exponents? X to the exponent of minus a is 1 over x to the exponent of a, which means you simply remove the negative by introducing 1 over. So this will be 1 over 8 to the exponent of a third. How do we remove to the exponent of a third? We are now back to the law x to the exponent of a over b, which is the bth root of x to the exponent of a. So this is going to give us 1 over the cube root of 8 to the power of 1, which is 1 over the cube root of 8, that is 2 to the power of 1, which is 2. So it's going to be 1 over 2. So that was the idea on this one. Okay, number 6, we're given a certain condition given that xy is equal to x plus y. So what does it mean? Find these values p, q, whatever that we have. So we have to multiply xy, means we are multiplying this 2, 0, 0, 6 multiply by y here, which is p, q, 0r is equal to the sum of x plus y. So you add x and y, which is 2, 0, 0, 6 plus y here, which is a p, q, 0r, like that. That is what they mean. So using our row by column concepts, row by column here, which is going to be 2 times p, that's 2p plus 0 times 0, which is 0. Row by column here, that's 2 times q, which is 2q. 0 by 3 r there, that's 0. We move on. Row by column, 0 times p, that's 0 plus that's 6 times 0 here, which is 0 also. 0 times q, that is 0 plus 6 times r here, which is 6r. So whatever that we get is equal to, here we are adding, so we're going to add 2 plus p, which is 2 plus p, 0 plus q, which is q, 0 plus 0, which is 0, 6 plus r, which is 6 plus r, like that. We can't simplify, just leave it like that. Okay, so that's it. Here we can just combine 2p plus 0, that's 2p, 2q plus 0, that's 2q. This one is just 0, this one is 6r, which is equal to 2 plus p, q, 0, 6 plus r, like that. So what do we know? Actually, we are left with two matrices, one on the left and the other one on the right, and we know that these two should be equal. Corresponding elements should be equal, so it means 2p is equal to 2 plus p. We can solve for p. Transpose to this side is 2p minus p, which is equal to 2. 2p minus p simply means 2 minus 1, which is p is equal to 2. We are done. We move on to q here. So it means here 2q is equal to q. So you can transpose here this q to this side, which is 2q minus q is equal to 0. The moment we transpose this, it means we are going to be left with 0 here. All right, so 2q minus q, that is q, which is equal to 0. We do the same for r here. 6r is equal to 6 plus r in this case, so you can transpose as r to this side is 6r minus r, which is equal to 6. 6 minus 1r is 5r, so 5r is equal to 6. We can divide by 5, so that means r is equal to 6 over 5, or 1 and 1 over 5. So these were the possible values that we were supposed to get: p, 2, q, which is 0, and r, which is 6 over 5. So it was a play around type of a question where you have to understand the question and play around the information that you're given from there. All right, the other part of the question on question 7, you're given that a bicycle wheel has got a diameter of 70 centimeters. This is a wheel, which means we're talking about something which is a circular form, and it has a diameter of 70 centimeters, which means we've got something like this, which is 70 centimeters. So the question, take pi to be 22 over 7, calculate the circumference of the wheel. So remember that circumference is equal to pi d, or you can use 2 pi r. Remember, 2 times radius is diameter, so you can use 2 pi r, but using 2 pi r, you have to find the radius. This is diameter of 70, so it means the radius is going to be 35. So we just choose which one to use there. Okay, so using 2 pi r is 2 times pi, which is the pi that you are given. Take note, guys, I told you always to use the given pi. The pi that you're given is the one that you're going to use, which is 22/7 times the radius, which is 35. So as you can see, it's a repetition because 2 times 35 is still 70, that one. So it's 70 times 22/7. 7 into 70, that's 10, which is 10 times 22, which is 220 centimeters. So that is the perimeter of the wheel, or the circumference of the wheel, the distance right around the wheel. So the question now on B is the number of revolutions made by the wheel in traveling 55 kilometers. So you're saying this is the circumference of the wheel here, which is 220 centimeters. So how many 220 centimeters are we going to have in this 55 kilometers? Because we are traveling 55 kilometers, how many cycles is it going to complete? These are the revolutions, complete cycles that are going to be completed. So here it's just going to be the number of kilometers, which is 55 kilometers, divided by the perimeter of the wheel, which is 220 centimeters. But as you can see, these two cannot cancel. These are kilometers, these are centimeters. We have to convert kilometers to meters. Remember that in a kilometer, we've got 100,000 centimeters. So it means 55, you're going to multiply 55 times 100,000, which is going to give us 55000 like that centimeters over 220 centimeters. Okay, so that's it. We can actually divide each here, cancel the zeros, then we can actually reduce stage by stage. We can even try by 11 here, because 11, that's 2 here, 11 here, that's 5. 2 into 2, that's 1. 2 into 5, that's 2. Remainder 1. Into 10, that is 5. Here it's a 0. Here it's a 0. Here it's a 0. So it's going to be 25,000 revolutions. 25,000 revolutions are going to be completed. So I just cross-check on the reducing part, if I manage to reduce properly those values, but that is the idea there of the question. Number 8, from the list, from the following list of numbers, write down the irrational numbers. We know that irrational numbers are those numbers which are not exact. They are not exact at all. If you express them as decimals, they are not exact, they are endless decimals. So 0.5, that's a rational number. This one is also a rational number. Then we've got a pi. This one is an irrational number. You can't simplify pi. It's same as 22/7. This one is an irrational. Square root of 81, we know this is plus or minus 9. So this one is already rational. You can simplify it. Square root of 2, we do not know the square root of 2. So it's an irrational number. Square root of 5 is also an irrational number. This one is already complete. So this one is a rational number. Remember, 3/4 as a decimal is 0.75. So this one is an exact value. It's exact. So it's a rational number. So the irrational numbers was pi, square root of 2, and 5. The rest are rational numbers. All these numbers that I have put in circles, they are rational, because the question can ask you to list the rational numbers in another question. So you must also know the difference between these two. All right, number 9, solve the inequality. So guys, I told you in F, we've got two inequality signs. These are simultaneous inequalities where you have to divide them into 2 from the middle term, which is 10x. So it is going to be 5x minus 5 less than or equal to 10x. Then we move on to the other one. We start with 10x. So it's going to be 10x is less than 8x plus 10. So that means we can solve. All right. So solving the first part, I can just leave this minus 5 on the left-hand side, which is less than or equal to 10x. The 5 to this side of the equation is going to be minus 5x. Minus 5 is less than or equal to 10 minus 5, that is 5x, divided by 5 both sides, divided by 5 both sides. So it means x is greater than or equal to -1. Okay, so that's what we have on the first one. Remember, we have grouped into 2. We have to solve the other part here, which is just have to transpose this side. That's 10x minus 8x, which is less than 10. 10 minus 8, that is 2x is less than 10, so you can just divide by 2 by 2. That's x is less than 5. All right, so as you can see here, we're already given the format x is greater than or equal to, which is this one, x is greater than or equal to minus 1. The same x is less than what? Less than 5. So you're just writing your answers in that form. Make sure that this is the minimum and that is the maximum value. Okay, then the B part, illustrate your solution to A on the number line below. So our solution is going to be taken from -1 up to 5. So -1 is less or greater than or equal to is involved. This one, we are involving -1, but 5 is not involved because x is less than 5. So you just put a circle which is not shaded. All right, then from there you can just join whenever you're given two inequalities, you know that they will join at the end. So that was it, just like that, guys. You're done. So these are some of the typical questions that you can have. All right, on the 10th part, shop assistant is paid a basic wage. So this one is paid a basic wage of 3,600,000 per week. In addition, she's paid a commission of, take note, this is in addition, she's going to be given 2.5% commission of the goods, of the value of goods which she sells. During a certain week, if she sells 52 goods which are worth $52 million, calculate the amount of commission. So take note, commission is from the percentage of the goods which she's going to sell. So in this case, we've got a percentage of 2.5. 2.5 is simply 2.5%. So here we are told that in this certain part, she had to sell goods worth 52 million. So the commission is simply 2.5% of this. Remember how you remove percentage, you divide by 100. So it's 2.5, which is 2.5% over 100 times the amount of goods that she sold, which is 52 million. All right, so that was it. So the one, the zero there, the cancel here. So here is just multiplying 2.5 times this. Okay, you can just put these zeros here. That's how many zeros? 4. 1, 2, 3, 4. Then it's 52 times 2.5. So if you multiply properly, 2.5 times 52, you get something like 130. So it will be 130, which means she had a commission of 1,300,000. That was the commission. All right. Then the B part now is her total earnings for that week. Remember, this person is having the basic wage. This is the wage per week of 3,600,000 plus the commission. She's given a commission of 1,300,000. So this is your commission. So you're just going to add the 2 here. That's 9 and that's 4. So it's going to be having 4,900,000 as the total earnings for that week. So that was the play around of the question. You just needed to play around that question so that you actually understand what's happening there. All right. Then the question 11, we are given that there are two towns x and y which are such that the bearing of x from y is 0.31. So take note, it's x from y like this. Something like this here, x from, we are starting from y, and it's a 3-figure bearing. Remember the presentation, that's a 3-figure bearing. And I told you it's safe to take taken in a north, from the north in a clockwise direction, somewhere there. So just assume that one is in between 0 and 90 degrees. So that's where we are starting at y. We end up at x. At x, we are going to have just our north pole here at x. So the question now is from A, find the bearing of y from x, that is y from x, which means we are starting from x in the clockwise direction, from the north pole of x in the clockwise direction. So that is the angle that we need. So as you can see here, remember I told you these lines, they are going to be parallel to each other. That means if this angle here is 31, also this angle here is 31 degrees. But remember, here it's a straight line. So you've got a combination of a straight line of 180 degrees and this 31 together, we can just combine to find the actual angle, which is going to be 1. That's 11 which is 1, which is 211 degrees. Okay, so that was the bearing of x from y, which is 211 degrees. All right, a third town Z is on a bearing of 300 degrees from y. Okay, so now find, okay, so there's another one which is from take note where we are starting from y. So which means we are going to do the same thing, just like what we did from the same point y, but now we are having 300. So 300 is greater than 270, but less than 360. So 300 is somewhere here. That is where we are going to have our Z. Okay, so that is where we are going to have our town Z here. So we are told that from y here, going to Z, that is this angle is 300 degrees. This is the bearing that we are given of 300 degrees. And the question now is find Z, Y, X, Z to Y to X. Remember, this is our point Y here. So that means we need this angle that is inside here. That is the angle that we are supposed to calculate. So what can we do? Remember, we know from this point here to this point, we know this distance here, this angle is 31 degrees, which means if we can be able to know from this point to this point here, it's going to be easier because we just have to add these two angles. So how are we going to have this distance? We're simply going to subtract this 300 from 360 because 300 is starting from the north of this point up to this point. So you just have to subtract from 360 so that we can have this distance. So it's 360 degrees minus 300 degrees, which is going to give us 60 degrees. So here we've got 60 degrees. So at the end now, we are going to add 60 plus 31. Well, that is the angle now, 60 plus 31 degrees, which is 91 degrees. All right, so this is going to be 91 degrees. All right, so that was the condition. Actually, it was a play around type of a question again, where you have to understand the basic approach of bearing. All right, number 12, the diagram above is a regular pentagonal style. So the moment that you are given regular, it means all the sides, all the angles, they are the same. State the number, state the order of rotational symmetry of the pentagonal spinner. Remember, guys, I told you that the number of sides is actually going to represent the order. So here's a 5, so it's going to be, it can be 1, 2, 3, 4, 5. That is the number of sides which are there. So this one is just going to be 5. Draw in all the lines of symmetry of the pentagonal star. So we need the lines. Remember, line of symmetry is going to divide this into two equal parts. Like we can divide it like this, we can divide it like this, we can divide it like this. So these are like what we need, lines of symmetry. So let's see if we can be able to represent actually what we need here. Okay, something like this. Something of this nature. All right, I just need something here. All right, something of this nature. Now it's because you see when these papers are being scanned, it won't be directly to that point, but it was supposed to be like this. That's a line of symmetry because it's going to cover up everything. We do the other one from this point and that point again, like this in the same way. So a line of symmetry has to divide your shape into two equal parts. So we've got 2 here. We do the same from this one to this one here. All right, like that. So you're just going to have our points from those arrows that we are given at the end. So that was the idea there. Another one, it was supposed to be like that from this point. So guys, we must just draw something, lines which are nicer than the ones that I'm having here. Yours should be much nicer than the ones that I'm having. So actually, that is how it was supposed to at least look like, up to the last one. After the last one like this, so you can just have another one, and the last one will be taken from this point here to this point. So it's something of this nature. All right, let me just try and do this. All right, something like this. So I think actually these were the lines. We've got 1, 2, 3, 4, 5, just like that. Okay, that's lines of symmetry. So it was just a presentation which was needed on this one. Just present properly on the diagram. All right, solve the following simultaneous equations. So whenever you're solving simultaneous, you're gonna choose the method. So I'm going to work on elimination, making sure that x is the same. So which means I have to multiply by 3. Remember, I just have to interchange here. So I have to multiply by 2 on top, by 3 down here. So 2 multiplies everything is 2 times 3, which is 6x. 2 times 2, which is 4y, is equal to 2 times 0, that's a 0 here. 3 times 2, that's 6x. 3 times y, which is 3y, is equal to 3 times minus 2, which is minus 3. So to eliminate x, we can just subtract equation 2 from equation 1. That's 6 minus 6. That's a 0 here. 4 minus 3, which is y, is equal to 0 minus minus, which is a plus. Take note, it's a minus and a minus, which is a plus. So y is equal to 3. So to find the value of x, you're just going to choose any one of these equations, substitute from there. 3x plus 2y is equal to 0. 2y, y is equal to 3. So since y is equal to 3, you can substitute. So it means 3x plus 2 times 3, that's 6, which is equal to 0 here. So 3x is equal to minus 6 divided by 3 by 3. So x is equivalent to what? To negative 2. So that's what we had. All right, 14, we are given OA, OB. These are the vectors that we are given, vector OA, vector OB, and X is the midpoint of OA. Take note, X is the midpoint of OA. Express vector OX. Since X is the midpoint, therefore OX is just going to be half of what? Half of OA. That's what we are given. That's a midpoint. So it's going to be half of vector OA. Already vector OA is given as 10 minus 2. So what is the half of this? Half of 10 is 5. Half of minus 2 is minus 1. So this is vector OA. All right, what about AB? This one is the modulus of AB, so which means you're supposed to find AB first. So AB is going to be, since we're given OB and OA, remember I told you it's OB minus OA. Last vector minus first one. So it's OB minus OA. Know your formulas, guys. All right, so OB, that's 110. So it's going to be 110 minus OA, which is 10 minus 2. So as we can simplify, 1 minus 10, that is negative 9. 10 minus 2 is a plus, which is going to be 12. But here we need the modulus now of AB. So after finding AB, what is there for the modulus? Remember that the modulus is the square root of x squared plus y squared, where this is your x, this is your y. So it's negative 9 squared plus 12 squared, which is 9 squared, that's 9 times 9, which is 81 plus 144. So if we are to add 81 plus 144, we are going to have a total of 225. So this is going to be the square root of 225. Remember, square root of 225 is 15. So this one is going to be 15. That is what we had. So it's 15 units or just 15. That was the modulus of this. Okay, so as you can see, guys, these questions are actually play around because you've worked with many questions now, so it's just a matter of understanding the concept. Anyways, in the diagram, we are given A, B, C. These are straight lines centered at O. So from the concept that we are given, calculate a MN. So how can we have these angles? That is, we have to apply from our vector. So in this one, I'm just going to do a fill-in method, or we can just answer direct a MN, that is A to M to N here. This is the angle that we actually need, AMN. So it's gonna depend with the way, but remember that ABNM is a cyclic quad. This angle of 68 is an exterior angle, and we know that the exterior angle is equal to the opposite interior. This is the interior angle, this one, but the opposite one is this one. So this angle here is 68 degrees. So we are going to have 68 degrees. All right, the B part is MAN, M to A to N, which means we are referring to this angle here. MAN. So which method actually can we apply? We can actually have the angles from the angles at the center. Let's see which theorem to use. Consider this diameter. Remember that a diameter actually subtends an angle of 90 degrees at the circumference. So AM is a diameter. So it's going to subtend an angle of 90 degrees at the circumference here. So if this angle is 90 degrees, therefore MAN, we just have to subtract. We can just add these two angles, 68 plus 90 from 180 degrees, or you can just subtract direct 90 minus 68 degrees. All right, so we can actually have this angle. So 90 minus 68, which is going to give us something like 22 degrees. So this will be 22 degrees. All right, then we move on to the C, which is BOM. So we've got B to O to M. Okay, let me indicate this one first. We say this one is 22 here. So now we need BOM, which is the whole of this angle, this one. Okay, I want you to notice what is happening here from B to M. From B to M, this is a chord that you're having here, B to M. This chord BM is creating angle at the center at O. The same chord BM is creating angle at the circumference there. So you know that the angle at the center is twice the angle at the circumference. When I'm referring to the angle at the circumference, I'm referring to the sum of these two, 40 and 22, which is 62 degrees. Is the one that is being created by BM, is creating the whole of this angle at A. So to bring this A at the center here, you multiply by 2. So which means this one is going to be 62 degrees times 2, which is going to be 2 times 2. That's 4. 2 times 6, which is 12. So it's going to be 124 degrees. All right, so that was the idea on this one. I think it's clear. Let's see the other part of the question. On number 16, we are given that the graph below shows the minimum daily temperatures over a period of 10 days at a very cold place. So these were the temperatures which were recorded at a certain place. Temperature, like day 1 here, it's -2. Day 2, it's 1. So you just correspond this value. Day 3 is 0, something like that. Okay, so it's something that you can study and see what's happening here. So the first question is, from the 10 recorded temperatures, find the modal temperature. So actually the modal temperature is the temperature that is appearing the most. That is the modal temperature. So you have to note which temperature is appearing the most here. So you can cross-check on our temperature. -2 is appearing 2 times. We've got -2 at this point, and at this point, 1 is just 1 time, but 0 here, it is appearing at this point. It is 0 degrees here, directed 0 here. This is 0 degrees, here 0 degrees, here 0 degrees. So as you can see, actually 0 is the one which is having most, which is appearing most. It appeared on day 3, it appeared on day 6, it appeared on day 9, it appeared 3 times. So the modal temperature was 0 degrees Celsius. All right, then the median temperature. So we know that the median temperature is actually the one that we are going to have as the middle term. So in order for us to know that median temperature is, we can actually arrange our temperatures here. These are the temperatures. So you can even write them aside, guys, so that we can write in terms of minimum, because it's supposed to be median is the number, the middle term that you're going to have. All right. So here we have got -4 as the, so it depends with what you want to start with. So I'm going to start with -4. So we've got -4 followed by -3. This one is supposed to be -3 if I'm not, yes, that's -3, -3 are 2. So it's -3, -3, then we move on to -2 and -2. So I'm just listing the temperatures, -2, -2. After -2, we move on to -1. Yes, -1 is just there, -1, which is 1. Then we move on to 0, 0, and 0. There are 3. So it's 0, 0, 0 like this. Then we have got 1. So which one is the median? After arranging our numbers in order of size, we're going to have -4, 1, -3, 0, -3, and 0. minus 2 and 0. So as you can see, in the middle, we are left with the two values, minus 2 and minus 1. And we know that when it is like that, you add your values. So it's the median is going to be minus 2 plus minus 1. So it's minus 2 plus minus 1 over 2. Minus 2 plus minus 1 is same as minus 2 minus 1, which is minus 3 over 2. So 2 into minus 3, that is minus 1,5 degrees Celsius. So that was the median temperature of minus 1,5. All right. Then the last part is see the temperature range. Take note, temperature range means maximum minus minimum. That's it. So that's a temperature range. So the maximum temperature recorded was what? That's what we need. As we can see, the maximum temperature recorded was 1 degree Celsius. The minimum recorded was minus 4. So it's 1 minus that minimum temperature. We said the maximum temperature is 1. The minimum temperature was minus 4. So you subtract 1 minus minus 4, which is 1 plus 4. So 1 plus 4, which is equal to what? 5 degrees Celsius as a positive. So that is the temperature. Whenever you're given about range is maximum minus the minimum of what you're given. All right, so let's see the other part, which is on question number 17. All right, so here we actually need these instruments. We are given that on this triangle, we are supposed to be doing construction. Paper 1, guys, you have to go with your math set because you can find any question on construction, anything, okay? So the question is on the diagram, X, Y, Z, above, use ruler and compasses only, to construct the locus of points which are equidistant from Y and Z. Okay, so equidistant from Y and Z, guys, I told you, equidistant from 2 points. That one is a line bisector. So you're supposed to bisect the line. Remember, to bisect the line, we just have to open more than half of the line. Sorry. We just have to open more than half. I just hope this is more than half of the line, because here this one is too big, or I can just reduce so that it can be fine. Guys, let me just reduce the PDF like this. I hope you can see properly. So remember, to bisect a line, you open more than half of the line. Then we have to mark an arc from one side. So I'm just going to mark an arc from one side, another arc on the other side, like this. That's something. Then from this other hand, we do the same. So I'm just going to drag this PDF a little bit down. All right, so like this, we can step at this point. Then we have to mark an arc from that side. All right, I need to shift it like this. Okay, we have to mark from this point here. Is it direct? Yeah, at this point direct. Mark this arc here, then down at this point. We have to mark like this. As you can see, these arcs, they do meet at a certain point. Where these arcs meet, then we are supposed to join these arcs. All right, so let's join them. All right, we're not going to waste too much time. Let us quickly have these points joined. All right, so that was actually the idea of this question. So guys, please make sure that you revise, and don't be surprised to find such typical questions in exam. Construction in paper 1, it's very, very possible like that. All right, so here we're just going to join parts that we are having. All right, so that's it. That's the locus of points equidistant from Y and Z, or it can be Y to Z. It's just one and the same thing. All right. 5 centimeters from the midpoint. Take note, guys, what they're saying. 5 centimeters from the midpoint. It's a point, that one. So it means whenever I told you locus of points equidistant from a point, it's a circle that you're going to draw. But you're drawing a circle from the midpoint of YZ. That is where we are going to have our circle, from the midpoint of YZ. This is the midpoint of YZ. Remember, when we constructed the locus of points equidistant from Y and Z, we said it's a line bisector, meaning to say it is bisecting this line into 2 equal parts. This was 10 centimeters. It means from the midpoint to this part, it's 5 centimeters. So all you need is to step at the midpoint, which is here. Okay, measure your 5 centimeters. Definitely your 5 centimeters is the half, which is at Z there, which is the same half as it goes to Y. So the moment you draw a circle like this, it must pass through Y and also pass at Z, like what you are seeing here. Supposed to pass direct at Y here, direct at Z here. So that was the midpoint. This is the mid. It's a point. It's a fixed point, the midpoint. So that was what the question was about. So as you can see, guys, that was our question. 17 was on construction. Locus, you have to understand these typical questions, especially paper one here, they can ask this. Okay, number 18. A varies directly as the square. Take note, the square we're talking about to the power of 2. So that's A varies directly as the square of R. Write down an equation connecting R and a constant K. So it's A is equal to K squared. So this is the equation. You are done. Okay. The B part, given that A is a 32.5, when R is 3.5, find the value of the constant R. So just substituting A is 38.5, which is equal to K R squared. So given that R is 3.5 squared times what? Times K. So you need to find the value of K in this case. So we can express this as improper fractions. That's 38 times 2, which is something like 76 plus 1, which is 77 here. So it's 76 plus 7. So it's 77 over 2, which is equal to 3.5 is same as that's 3 by 2, which is 6, which is 7 over 2. So it's 7 over 2 squared. 7 squared, that is 49 over 4. So this is going to be 49 over 4 times K. So then are we going to find the value of K? We can cross multiply. Yes, we can do the cross multiplication here so that we can get rid of these numbers. So 77 times 4. So you have to multiply, guys, properly there, which is going to give you 308. So 308 is equal to 2 times 49, which is 98. That will be 98, yeah. So that's 98K. Divide by 98, divide by 98, we can find the value of K. So K is equal to what? So there, guys, I want you to divide properly. You're supposed to obtain something like 22 over 7 if you divide properly. So that was the constant. So I want you to try this and reduce, guys. That's what you're supposed to have. Okay, number 19. We are given the logarithm of 7, the logarithm of 2, then find log 14. Okay, I explained this part earlier on. We just have to ask ourselves, where can we have this 14 from 7 and 2? We found this by what? By multiplying the two numbers, 7 times 2. 7 times 2 is 14. So you can separate 7 times 2, which means we can have log 7 plus log 2. Remember, from your log mn is equal to log m plus log n. So that's 2 times 7. So you're going to add log 7. We are already given this is log 7, 0.845 plus log 2, which is 0.301. So you can add 1 plus 5, which is 6, 0 plus 4, which is 4, 3 plus 8, that's 11. Then we give a 1 here, comma. So it's 1 plus 0 plus 1, which is 1. So it's 1,146. All right, then the B part is log square root of 2. Which law am I going to use? Remember, guys, I told you log m to the power of p is equal to p, the logarithm of m. So you can try to play around this because we can rewrite the square root from our laws of exponents. We know that square root means to the power of a half. So once it is log 2 to the power of half, we are now back to this condition where we can drop this p to multiply the log, which means we can drop this half here to multiply the log. So it's half log of 2. Which is half times log 2. Our log 2 is this one that we are given, 0.301. So let's divide here 2 into 0, that's 0, 2 into 3, that is 1. We've got a remainder of 1. 2 into 10, which is 5. Then 2 into 1, which is 0. We put a 0 here. Then 2 into 10, which is 5. So that was the logarithm of the square root of 2. So it was just a play around again. Number 20, expressed as a common fraction in its simplest form. So is this as a common fraction of this, of this. So what was it, guys? Here we just divided, isn't it? That's our A, as a common fraction of in its simplest form. All right, so let's see 3 times 10 to the power of 4. Is it minus 4 or 4? I don't know there. 5 times 10 to the power of 2. So this will cancel here. Okay, because this is going to be 2 here. There are 2, so it's going to be 10 to the power of 2. That means here is going to be 100 times 3, which is 300 over 5. 5 into this, that's 60. It's giving us a whole number here. Okay, anyways, this is giving us a whole number. Maybe it was a negative 4, I don't know. Okay, the B part, express 1, 0, 0, 2 in base 3 as a number in base 7. So remember, we have to convert to base 10 first, where we have to rise in powers of 3, 3 to the power of 0, to the power of 1, to the power of 2, to the power of 3. So it means it's 1 times 3 to the power of 3, plus here it's a 0, so there's nothing to write there. Then 2 times 3 to the power of 0. All right, so that's it. 3 to the power of 3, that's 27, plus this nothing here. 3 to the power of 0, remember it's 1. 1 times 2, which is 2, so it's going to be 29. Which is in base of what? Which is in base of 10. So from base 10 to base 7, we're just going to divide. That's 29 divided by 7, noting all the remainders down. So it's 7 into 29, which is 28 is 4, remainder 1. 7 into 4, that's 0, remainder 4. So from the bottom going up, that's our answer, which is 4, 1, base 7. All right, so that was the idea there. I think also it was pretty clear. Yeah, it was pretty clear. 21, in the diagram, ABC is an isosceles triangle. So you're given this in isosceles. What do we know about an isosceles? Those are the things that you're supposed to know. If you are given that these two sides are equal, it means base angles are equal. Base angles, these are the angles which are opposite the sides which are equal. These ones are opposite. So if this is 5x, this is also 5x, opposite. So these two are equal. Okay, anyways, and all these angles, and this is a straight line, where we know that angles on a straight line, they add up to 180 degrees. Anyway, the question is find the value of x. So how can you find x? Using this triangle, we can take advantage, because remember, we said these are base angles which are equal. And we know that angles in a triangle, they add up to 180. So we can formulate an equation to say, if we add these angles, we must get 180 in a triangle. So it's 5x plus 5x plus 50, which is equal to 180. 5 plus 5, that is 10x plus 50, which is equal to 180. So it's 10x is equal to, transpose here, 180 minus 50, because it was a plus, so it will be minus 50 on that side, which is going to be 130 degrees. So you can divide by 10 by 10. So our x is going to be 13. So the x that we see here is simply a 13. All right. What about the value of y? We can use this as a straight line here, taking advantage of a straight line to say that angles on a straight line also, they add up to 180 degrees. So meaning to say, we have our x, which is 13. So here we're going to substitute is 3 times x, which is 3 times 13, and 3 times 13, that's 39. So it's 39 degrees. So here we've got 39 degrees. So to find y, we're just going to add everything on a straight line. That's y plus 39 plus 50 here should give us 180 degrees. So y plus 39 plus 50, that's 89, which is equal to 180 degrees. So to find y is going to be 180 minus 89 degrees. That's y is equal to 91 degrees. All right. So our y is going to be 91 degrees, or just 91. So that was the condition. Yes, we've got the value of y, which is 91. Let's see the other part that we have. So these questions, I don't know if you can understand from the basics that we had. These questions are just like to open you up to be able to answer the typical questions that you might have on your final. So I just want you to have that idea of what was actually happening on these papers. Just one and the same thing, actually. Okay, number 22. Mrs. Mulia and Mrs. Moore share 50 kgs of millimil in the ratio of 2:3. Find the mass of millimil Mrs. Moyo gets. So here we're given a total. They have to share 50 kg, so that is the total according to the ratio. So you add your ratios, 2 plus 3, which is 5. So according to 5, that is the one that is equal to the 50 kgs they are sharing. But remember, according to ratio, this is Mrs. Mulea and this is Mrs. Moyo here. All right, so we need the one for Mrs. Moyo. Moyo has got what? 3 according to the ratio. So it's the one that we need with 3. So what is the total for these 3? We do not know. So simple proportion is going to be less. That's 3/5 times 50 kgs, just like that. You're done. So it's times 50 kgs, sorry. So 5 into 50, that's 10. 10 by 3, which is 30 kgs. All right, the B part, we are given a motorist covers a certain distance in 15 minutes when his average speed is 60 kilometers per hour. Find the time taken by a pedestrian walking at the average speed of 5 kilometers per hour to cover the same distance. Okay, so here we want to calculate the time, but do we know the distance that that was covered? We do not know. So from the first one that we are given, it is going to help us to know the distance which was traveled. If we know the distance, then we can be able to calculate the time on the second one. Okay, so the first part, we are given time. Remember, your time has to be in hours. We are given 15 minutes. How do you convert minutes to hours? We divide by 60. So that's our time. The speed is already in kilometers per hour is fine, which is 60 kilometers per hour. So how do we convert? How do we find distance? Remember, from our DST. From our DST, distance is speed times time. Here, speed times time. So our distance is going to be speed times time, which is the speed of 60 kilometers per hour times the time, which is 15/60. So you can reduce out this 60 and 60 cancel, which means our distance was 15 kilometers. But this is not the question. We now know the distance that was traveled, because here we are told that this pedestrian is going to cover the same distance. Which distance? This one of 15 kilometers that we calculated from the first option that we had. So since we now have a distance of 15 kilometers, now the question is calculate the time. So we need time this time. So time is equal to distance over speed. So it's distance over speed, which is the distance of 15 kilometers over the speed. The speed was 5 kilometers per hour. So it's 5 kilometers per hour. So if we can reduce this, it's going to be hour here, 5 into 15, which is 3 hours. Okay, so that was the time which was taken. So the answer is going to be 3 hours. But you see, we had to use the first information to find the distance, then the second information now to find the time for the pedestrian. All right, so that was the idea actually for this question. As you can see, it was just 4 marks for everything, part A and part B. All right, number 23, we are now given tan x is 5/12 and find as a common fraction. I talked about this question in our previous class when we did 2000, it was actually, yeah, 2009, I talked about this type of a question. Actually, for tan, they will not give you like a certain consideration, like a range of values of x. You must know that when your tan is positive like this, it means this tan that we are referring to is an acute angle. So we are referring to tan, which is an acute angle. So it's just like a normal right angle triangle. Let me just put it here, just like a normal right angle triangle here. It's an acute angle that we are referring to. So let's just say this is our x degrees here. And we are given that this tan x is 5/12. And we know that the ratio of tan from our SOHCAHTOA here, tan, it's opposite over hypotenuse. So it's opposite over adjacent, I mean opposite over adjacent. So it's according to this x here, that's your opposite, which is 5, the adjacent, which is 12 here. So you can use the Pythagoras theorem to calculate the third side, which is going to give you 13 if you apply the Pythagoras theorem properly. Okay, so that was the diagram that you're supposed to have. So the question now is calculate as a common fraction or find as a common fraction sine x. So you know that sine, that's opposite over hypotenuse. So our sine x is going to be the opposite over the hypotenuse. And according to this, the opposite is 5/13. So that was the case or the idea in this case, just like that. All right. Then the B part is cos 180 degrees minus x. According to this x that we see here, 180 minus x is this obtuse angle, which is on this side. Because remember, if this is 50, this is 180 minus 50. So if this is x, this is your 180 degrees minus x. And we know that it's an obtuse angle that we are talking about here. It's an obtuse angle. So what do we know? We actually know that cos of an obtuse angle is equal to the negative of the cos, which is an acute angle. So what you're going to simply do is to calculate the cos of the acute angle, which is the cos of x, which is inside here, where we know that our cos is adjacent over the hypotenuse. So it's going to be minus the adjacent, which is 12, over the hypotenuse, which is 13. So this will be cos 180 degrees minus x, which is negative 12 over 13. So then it was an understanding to know that this is an obtuse angle that you're talking about. So if it is an obtuse angle, cos and tan, they are negative for all the obtuse angles that we have. Cos and tan are the only ones that we have which are negative, or it's only sign which is a positive there. Okay, number 24, you're given a fair six-sided die is thrown 2 times. So it was thrown 2 times. Find the probability that the total score is at least 4. So here we're supposed to use actually an outcome table where we've got, remember guys, if you are dealing with a first six-sided die, we'll be having 2 outcomes here. We've got the first and we've got the second one on this side. So the first die is going to give us numbers 1 up to 6. 1, 2, 3, 4, 5 up to 6. These are the outcomes that we expect. The second one is going to give us the same outcomes 1, 2, 3, 4, 5, 6. So these are the outcomes that we expect. So now the question is, from these outcomes that we see, what is the condition where we are going to have the total score, which is at least 4? We just need total. So which means total we have to add. We are going to add these outcomes. That's a total. So what you're going to do, you add each corresponding elements is 1 and 1 here. I want you to see 1 and 1. So you add 1 plus 1, which is 2. 2 plus 1, which is 3. 3 plus 1, which is 4. 4 plus 1, which is 5. 6, and so something like that. 1 plus 2, which is 3. 2 plus 2, which is 4. So you're going to do like that. 6, 7, 8. We move on. 1 plus 3, which is 4. 2 plus 3, which is 5. 3 plus 3, which is 6, 7, 8, 9, and so on. 1 plus 4, which is 5. 2 plus 4, which is 6, 7, 8, 9, 10. We do the same. 1 plus 1, which is 6, 7, 8, 9, 10, 11. 1 plus 6, which is 7, 8, 9, 10, 11, 12. So these are the possible outcomes after adding. So the question is, give us a condition where we've got the least 4, the total should be 4, at least a 4. So which means at least a 4, it means 4 or more. That is what it means, 4 or more. So we are talking about where we've got 4 or more from these 4 that we have here. This is where we've got 4 or more, all these outcomes here. So how many outcomes are there? We have to count them. But instead of counting all this, we know that here we are supposed to have 6 by 6. We're supposed to have 36 outcomes. So out of 36, we're only going to remove 1, 2, 3. So 36 minus 3, which means we have got 33 outcomes out of 36. All these, they are more than 4. They are at least means from 4 upwards. Okay. So you can reduce by 3. Here, that is going to be 11 by 3, which is 12. So it's going to be 11 over 12. Okay, so that was actually the idea of the question. But take note here now, they are saying the 2 outcomes are different. The 2 outcomes are different. This is how you answer this one. You need a condition where the outcomes are different. So the table is going to change. Your table now was supposed to look like this. Okay. I'm just going to show you what your table was going to look like, but it's just a familiar type. But here, you are no longer adding the outcomes, because we need, when they say the 2 outcomes, which means we are just combining. Here it's 1 and 1, so we just combine 1 and 1, 2 and 1. So this one is 2 and 1, 3 and 1. So this one is 3 and 1, 4 and 1. This one is 4 and, so you combine like this. So where the 2 outcomes are different, you see that we are going to have 1, 1. We are going to have 2 versus 2. When you talk about these 2, we are going to have 3 and 3. We are going to have 4 and 4. We are going to have 5 and 5. We are going to also have 6 and 6. These are the only outcomes which can be the same 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. These are the only outcomes that are the same. It means the rest are different. Remember, we said 36 possible outcomes that we are supposed to have. But out of 36, it's only 6 which are the same. So what do? We just subtract them from 36. So 36 minus 6, that is 30. So this one, it is going to be 30 out of 36. These are the outcomes which are different. All right. So you can reduce by 6, that is 5. By 6, that is 6, is going to be 5 over 6. All right, so that was it. I think it was just something like that. Okay, name in correct order the triangle that is similar to triangle ABE. So okay, these are similar triangles similar to triangle ABE. That's A to B to E. Remember, guys, similar figures are supposed to be equiangular. You take them according to equal angles. So angle A here with D from our Z angle concept, angle B and angle C from our Z angle concept again, then angle E and angle E from vertically opposite angles. So we are going to take this similar to the one that is correspond to A here, triangle A. A corresponds with the D. B corresponds with C, E and E. So these are the similar figures. Okay, then we are given that if AD from A to D is 10 centimeters, find AE. All right, that means we have to play around with this information. We want to find AE, we are given AD. All right, so let us see what we can do actually here to find our AE. Because as you can see, AE, it's AD. This AD that we're talking, it's a combination of AE and ED. Our AD, it's a combination of AE to E plus E to D. Anyways, let us first apply our similar figures concept because we know that the ratio of sides is the same throughout. So you're gonna play around with the ratio of sides. Remember, that's gonna be AB over the corresponding side, which is DC, which is equal to B to E, that is BE, over the corresponding side, which is CE, which is equal to A to E, over the corresponding side, which is D to E. So let us fill in our information if we have got any ratio which is complete. AB, do we have AB? Yes, AB is 4,5. So our AB here is 4,5 over DC, which is 1,5, is equal to BE. Do we have anything about BE? B to E, there's nothing. A to E, let us move on to A to E. Okay, remember we want to calculate AE. So you can write it, AE is the one that we want to calculate. So we are going to take this last one, this one, there's nothing. So here we're going to take AE. So it's AE over DE. But take note, we do not have DE, we have got AD, but as we are given DE. So we are going back to this ratio that we talked about here. Remember, I said AD is equal to AE plus ED. So you can substitute here AD, which is 10. So AD is 10, which is equal to AE is the one that we want to calculate. So it's going to remain as AE plus ED, which is in this case, we can play around this ED. Do we have it? Okay, let's see. Okay, we do not have. Okay, so you just have to write it as ED. So as we want to write this ED in terms of AE, so it's going to be 10 transpose AE to this side, which is 10 minus AE, which is equal to ED. So ED is equal to 10 minus AE. Whenever we see 10 minus AE, we see ED. That is what we are given here. So from E to D, which is DE, is the same. So it's going to be 10 minus AE like this. All right, so that is what it means. So as you can see, now it's an equation with AE always. So it's AE here. Also, we have AE here. All right, so you can play around the ratio first. Let us play with 4,5 over 1,5. So it's 4,5 over 1,5. Can just multiply by 10 over 10, which is 45 over 15. All right, so reducing this by 5 is going to be 3. By 9, sorry, that is going to be 5 here. Sorry, okay, just use 15, sorry, by 15, 1, by 15, yes, 3. So it's going to be 3 over 1. So 4,5 over 1,5 is same as 3 over 1. So that means I can write this as 3 over 1 is equal to AE over 10 minus AE. So what have I done? I have formulated an equation where I can solve for AE by just cross multiplying the 2 here. So it's 3 times 10 minus AE, which is equal to AE. All right, so let us expand brackets. 3 times 10, that is 30, minus 3AE, which is equal to AE. So you can transpose the AE to the right-hand side, which is going to be a positive. So it's 30 is equal to AE plus 3AE. So you can add 1 plus 3, which is 4. So 30 is equal to 4AE. You can divide by 4 by 4. All right, so that's it. We have our AE, which is 30 over 4. So you can even reduce by 2. That is 2 by 2. That is 15. So 2 into 15, that is going to be 7.5 here, or 7.5. All right, so that is our AE. So as you can see, it was actually that type of a question, guys, that had needed you to play around the values that you are given, work out an equation from there which consists of AE. Then from there, you can be able to find your AE. So this was important at this stage here. So actually, there are so many ways that we can work out this, but that was going to be the easiest way. Or you can just introduce your AE to say, let AE be equal to X. You use it as X. You solve for X. By solving X, you know that you are solving for AE. That would be another option again. All right. The 26th part, we are now given two quadrilaterals, PQRS, that is P to Q to R to S, A, B, C, D. So the first equation was describe fully the single transformation which maps A, B, C, D onto PQRS. So actually, we know for our transformation, we are supposed to at least join the corresponding point so that we can take note. What do we actually have as our transformation? Is it going to be an enlargement, a shear, or something else? Okay, so it's A, B, C, D, which is A, B, C, D onto P, Q, R, S. So if we are to join corresponding elements, they are supposed to join at a certain point. Let's see if that is going to happen in this case, so that we can have the transformation, because it's either we're going to deal with enlargement. If it is not enlargement, therefore it is going to be a two-way stretch. So this one, it's a matter of trial and error to locate which one exactly is the one that we are going to have. So these are corresponding elements. A corresponds with P. So we have to join A to P. Let us see what we are going to have. So after joining, you're going to see that these points, they are going to meet at 5, 4. That was actually 5, 4. So that means actually it's an enlargement, this one. So you can now describe it is an enlargement. It is an enlargement. So remember, for enlargement, you need the center of enlargement. Here the center is at X, which is 5, and our Y is 4. So center is 5, 4. Then we need the scale factor in this case. All right. So remember that the scale factor, you can actually work with the size, just measure corresponding side. But as you can see, here it's going to be 2 times this side to this side. So here it was actually going to be 2 times, but we have to measure properly and see. But by just looking here, our scale factor can be 2 then. So that means that's the distance that you're going to have, which is 2. Then the B, write down the ratio of area of PQRS to the area of A, B, C, D. So since these are similar figures, we know that from similar figures, the ratio of size, the scale factor is your ratio of size, this one that we see. So we have got a ratio of sides, which is 2:1 as our scale factor. But the question now needs the ratio of area, which is your area factor. So remember, guys, I told you the area factor, you have to square everything. So it's 2 squared, which is 4s to 1 squared, which is 1. So that was the ratio of areas from the scale factor. All you needed was to square the given ratio. All right, number 26, we're given among the members of staff at a school, 21 take T 12 they take coffee, 5 take neither tea nor coffee, and X take both tea and coffee. So complete the Venn diagram to show the number of elements in each subset. Okay, so this was a clear question, guys. You have to insert the values that we are given. Take note, we are given that here 5 they take neither tea nor coffee, which means they are not part of this set. They are not part of tea, they are not part of coffee. So we've got 5 which are outside of the set. Then X, they take both tea and coffee, so which means we've got X, which is in between the two sets here. Then 21, they take tea, which means the whole part of tea here is 21. What about those who are taking tea only? So it's going to be 21 minus X. The same thing with coffee here, there are 12. What about those who are taking coffee only? It's going to be 12 minus X. So that was it. Now the B part, we are now given if there are 35 members of staff at a school, find the value of X. So to find X, we just have to add everything equate to 35. So we're going to add 21 minus X plus X plus 12 minus X plus, also this 5 is supposed to be added. So you add everything, you equate to the total number of staff members which are there, which is 35. All right, so let us combine our numbers and see what we are going to have. So we have to add 21 plus 12, which is going to give us something like 33, plus 5, which is 38. So we're going to have 38 minus X plus X, that's a 0 here. This can cancel. We remain with minus X. So it's minus X, which is equal to 35. So you can transpose to find X here. 38 to that side is going to be minus 38. So minus X is equal to 35 minus 38, which is minus 3. Divide by minus 1 both sides. So X is equal to what? X is equal to 3. All right, then the item 2, we are now given to find the actual number of members of staff who take tea but not coffee. So they take tea but they do not take coffee, which means we are talking about those who take tea only, which is 21 minus X, of which our X is 3. So it's going to be 21 minus 3, which is going to give us 18. So those are the ones who take tea, but they do not take coffee. It's tea only. That is what it means on this one. Okay, so that was the question. Question number 27. All right, so let's see the other part, which is in the diagram below, it's a B, C. On question number 28, we're given the coordinates of A, B, and also the coordinate of point C. Find the equation of line A, B. So to find the equation, guys, I told you just have to find your gradient. Already you're given the points here. So you can find the gradient. Remember that your gradient is y2, the change in y over the change in x. That's y2 minus y1 over x2 minus x1. So you can just formulate our points. In this case, we have to write this as our x1, y1, x2, y2. So that means y2, in this case, that's minus 2, minus y1, which is 4, over x2, which is 4, minus x1, which is 0 here. So we've got minus 2 minus 4, which is minus 6 over 4. So it's minus 6 over 4. You can reduce by 2. That's minus 3 over 2. We have the gradient. We also know the y-intercept. Remember that our equation is supposed to be y is equal to mx plus c. Where I told you that y is equal to mx plus this c represents the y-intercept. The m here is your gradient. So you're just going to substitute the gradient. You have the gradient, which is minus 3 over 2. So it's minus 3 over 2x plus c. Our c, which is the y-intercept at A, which is plus 4. So that was the equation for line AB. Then the B part, we are now asked to calculate the length of the line AC. Leave your answer in set form. Okay, so the length of a line we are given, this is our A to C. So AC, you can actually use a lot of things. You can apply Pythagoras theorem, or you can apply the formula for length. Remember, I told you that you can apply the formula for length. So I'm just going to apply any of those formulas in this case. Okay, so let me just put it here so that I can be able to apply any formula which is applicable. So like I said, we can use Pythagoras theorem because from A to B, from A to this point here. Let's just name this point. We do not know, so let's just say O here. From A to this point, this is a vertical line. Here we have got a horizontal line, so it's at 90 degrees here. So you can even tell the distance according to units is 246. So this is 246. So we've got 6 units. This is 2, 4. We have got 4 units here. We want to calculate AAC. So it means our AAC, we can use Pythagoras theorem. Remember, h squared is equal to a squared plus b squared. H squared is the hypotenuse, which is your AC. So AC, we're using the formula. We have to substitute now our A and B, which are the smaller sides in this case. So it's going to be AC squared is equal to 6 squared plus 4 squared. So that's 4 squared plus 6 squared. All right. So AC squared is 4 squared, which is 16, plus 6 squared, which is 36. So that means AC squared you can add, that is 10, 40, 50. So to find AC, it's now the square root. So AC is the square root of 50, which is square root of 50 units. Or you can simplify further. Remember, square root of 50 is the same as 25 times 2, whereby square root of 25 is 5, and square root of 2, we do not know this one. So it will be 5 square root of 2. That was the length. Like I said, we could have used this formula for length. Remember, guys, I told you that the length of a line can be given by a formula, which is the square root of x2 minus x1 squared plus y2 minus y1 squared. So since we want the length of AC, this is our A here, the point A. Let me show you here. This is your point A, the one that we had here, and this is your C. So you are going to name our points from what we are given. Our A here is going to be x1, y1. Our C, this will be your x2, y2. Since we are referring to the length of AC, so it's going to be the square root of x2 minus x1. Our x2 is minus 4. So it's minus 4 minus x1, which is 0. So it's minus 4 minus 0 squared plus y2 minus y1. Our y2 is minus 2 minus 4. So it's minus 2 minus 4 squared. All right, so that is the length. Minus 4 minus 0 is minus 4. So it's minus 4 squared. Remember, square root of a negative, guys, is still gives us a positive. Okay, anyway, let us write minus 2 minus 4, that's minus 6 squared. All right, so a negative, once you square it, it becomes a positive. A negative, once you square it, it becomes a positive. So if you add, we are going to obtain square root of 50. As you can see, we are back here. We have got square root of 50 as our AC. So we are going to obtain the same answer actually. All right, so that was the question. Now the area of triangle ABC. Okay, so this is ABC. So for ABC, remember guys, this is at 90 degrees. From here, at this point to B is also 4 units, is 2, 4. So which means we are talking about an isosceles triangle. So you can use the base and height concept, where we know that the area is given by half of the base times perpendicular height. So that one is going to be area. It's half of the base times the perpendicular height, which is half of the base. What is the base in this case? We are referring from B to C. That's 4 plus 4, which is 8. So it's going to be half of 8 times the height. The height now, that's the perpendicular height of the triangle, which is 6. So that one, it's a 6. So half of 8, that's 4. 4 times 6, which is 24 square units. Here we are not using centimeters. It's going to be square units, because it's on the graph. We are not given centimeters here, so it's just going to be square units. So that was the area, guys. Or you calculate the number of boxes of 100 times area of unit square, the one that we did when we were doing our algebraic graph. But that one is going to be a little bit tiresome, because here we could have just used a formula direct like that. So as you can see, that was it. Number 28, let's see the other part, which is 29. We are given a velocity time graph here. The velocity time graph is for an electric train. So that is how the train was moving. It's a second before this and that reaching. So you read all the information, guys. Make sure that you read everything. Okay. Anyways, the question is calculate the velocity of the train at the end of the 8th second. Okay. I talked about this type of equation here, and okay, the 8th second is it's an approximation, maybe here, that's where we've got our 8th second. So at the end of 8th second, we mean the velocity which corresponds when our t was 8 at this point. We do not know this velocity here. We do not know it. So we are going to take advantage of the points that we are given because it's a straight line. And I told you guys that on a straight line, remember that acceleration is the same because acceleration is same as what? Is same as gradient. So you're going to calculate the acceleration and maintain that using the points which are there. So you're going to take this point on this straight line. So this is the point that you're going to use 5 versus 40. All right, so you've got 5 versus 40. Another point is 9 versus 80. So this one is 9 versus 80. So remember, acceleration is the change in velocity over the change in time. So guys, we are now used to these points. Just name your points. X1, Y1, the one that we are used to, Y1, X2, Y2. So it's going to be Y2 minus 1 over X2 minus X1. So let us substitute here. Y2, that's 80, minus Y1, which is 40, over X2, that's 9, minus X1, which is 5. So 40 minus 80 minus 40, that's 40 over 4, which is going to give us 10 meters per square second. So this acceleration of 10 meters per square second is the same even if you use the point of 8 versus V, which you do not know. So it's a point that we can take as an advantage, 8 versus V, and you take any one of these 2 points, just pick one. So I'm just going to pick the one of 5 and 40. If we are to calculate acceleration using these 2 points, we must obtain the same acceleration of what? Of 40. So that can be an advantage to say acceleration is already there, which is 10. So 10 is equal to, we now find acceleration. So it's 40 minus V. So it's 40 minus V, just using this formula the same way we did here, over 5 minus 8. So it's 5 minus 8. Okay, so that's it. This is same as over 1, so it's 10 over 1, which is equal to 40 minus V. We can't do anything here, so you just have to write it as 40 minus V over 3 minus 8, that is 5 minus 8, so which is negative 3. So cross multiply, we are going to have minus 3 times 10, which is minus 30, which is equal to 1 times 40, that's 40, 1 times minus V, which is minus V. So to find V, what are we going to do? Transpose the V to this side of the equation, it will be a positive V is equal to 40. Transpose the minus 30 to this side of the equation is going to be a plus 30. So V is 70 meters per second. So it means when our velocity was at 8 here, when the velocity was at 8, when the time was at 8, the corresponding velocity was 70. That was the corresponding velocity here. It was at 70 meters per second. All right, so that is the consideration. Now the other part is the deceleration. B, the deceleration during the last 5 seconds. Okay, what we have the last 5 seconds? This is our last 5 seconds here from 9 to 14. So remember that deceleration is equal to negative acceleration. So this is B. Deceleration is equal to negative acceleration. So we have to find acceleration first. Using the points that we are given, change in V over change in time. What are the points that we are going to take? We have got this point 9 versus 80. So we have got 9 versus 80. Another point of 14, this one is 14 versus 0. Our velocity there is 0. So remember our change in V over change, so it's 0 minus 80 over 14 minus 9. Okay, 0 minus 80, that's minus 80 over 14 minus 9, that is 5. So 14 minus 9, that is going to give us 5. All right, then if we divide, we are going to get minus 16 meters per square second as our acceleration. But here we said acceleration is the one that we are going to take from this formula, but deceleration is equal to negative acceleration. So our deceleration is going to be negative times the answer that we got of negative 16 meters per square second, and that will be negative times negative, which is a positive 16 meters per square second. That was our deceleration now. All right, let's move on. The total distance traveled by the train during the 14 seconds. So remember, guys, total distance, we have to find the total area. That is, sorry for that. Okay, I just want to remove part of this. All right, so remember that our distance, we have to calculate the total area. So here, I'm just going to separate a trapezium or a triangle, rectangle, trapezium, triangle, whatever. But here I'm going to separate like this. I have a trapezium here. The first one is a trapezium. The second one is a trapezium. So I've got two shapes, two trapezium. The last one is a triangle like that. It's fine for me. Or you can separate this the way that you want, guys. But remember that distance is equal to area. So our distance now is going to be, remember, area of a trapezium is half sum of parallel sides times the perpendicular height plus another trapezium, half sum of parallel sides times perpendicular height plus a triangle, half base times perpendicular height. All right. So in this case, what are the parallel sides from this first trapezium? Here we can see that these are the sides which will never meet. These sides are parallel. Remember, this from 0 to 5, that is 5. So it's half of 5 plus from here 4 to 5. 4 to 5 is just 1 here. So it's 1 times the height, which is 40. This is the height here. So you multiply to 40. So that's our first area, which is the first distance. We move on to the other trapezium, this trapezium. These are the sides which are now parallel this time. These sides, this one and this one, these are the ones which are parallel this time. So it is going to be half sum of parallel sides, which is 40 plus 80. So it's going to be 40 plus 80 times the height, which is from 5 to 9. This is now your height, which is a height of 4. All right. So that is the second one. We move on to the last one, which is a triangle. So what we have on the triangle, that's half base times the perpendicular height. So from 9 to 14, that is 5. So it's going to be plus half times base, which is 5, times the height. What is the height? From here to here, it corresponds with 80. So it's going to be times 80 like that. All right, so that's it. Then you can simplify, guys. As you can see, it's a matter of simplification now. Here it's 5 plus 1, that's 6. All right, so it's going to be half of 6, which is going to give us what? Half of 6, that's 3. 3 times 40, which is 120. We do the same, we add here 40 plus 80, which is 120. Then we can reduce half of 120, which is 60. 60 times 40, which is 24, which is 240. The same thing, we can reduce here 2 into 80, that is 40. Then 40 times 5, which is 200 years. So it's going to be 200. All right, so let's add 2, that's to be 0, 0, 0 here. 0 plus 4 plus 2, which is 6. 2 plus 2, that's 4 plus 1, which is 5. So that's our distance of 560 meters. So like I was saying, you can use any other way, separate this diagram in a way that you understand, but still you must obtain the same area like the one that we are having here of 560 meters from this area. Distance, sorry, is equal to the area under the graph. So as long you know your formulas, this is the right time for you guys to work with formulas. Know all the formulas in the syllabus so that you won't have challenges in your final exams. So that's it, guys, from Mason African Motives, working on O-level maths, past exam papers, till we meet again.